Find the solution of the given initial value problem. So we have a second order ODE and two initial conditions. So for this homogeneous, we have the characteristic equation r squared minus 2r plus 5 equals 0. Using the quadratic formula, we get 1 plus minus 2i. So these are complex conjugates. So based on this, our solution is just real part e to the t times c1 cosine 2t plus c2 sine 2t. Now we need to determine the values of c1 and c2 using these two initial conditions. So here is 1. Okay, let's use this first. But this t is pi over 2. So we got t here. Okay, if we had 0 here at 0, then e raised to 0 would be 1. But at pi over 2, so this t, if we had t minus pi over 2, and if we take t equals pi over 2, that would be pi over 2 minus pi over 2, 0. So we can make this one. So we can multiply this solution by a constant. Okay, for homogeneous, using the principle of superposition, we can multiply by a constant any non-zero number, and it's still a solution. Even with 0, that will be a solution, but then we get a 0 solution, which is trivial. We are not interested in that. So we want to multiply by e raised to, I want to get this one, right? So et is already there, so minus pi over 2. I want to multiply through by e raised to negative pi over 2. I mean, this is optional way to do it. The other option is, you can see another video I have worked out without multiplying by this. So we can update y when we multiply. So we multiply once, so just here e raised to t plus minus pi over 2 means t minus pi over 2, and everything c1 cosine 2t plus c2 sine 2t. Okay, this will be our solution later. Let's use first initial condition. So using y at pi over 2 equals 0, that means t is pi over 2 and y is 0. So y is 0 when t is pi over 2. So e raised to pi over 2 minus pi over 2, e raised to 0. I mean, that was the whole point of multiplying by this. We get 1. Inside c1 times cosine 2 times pi over 2, cosine pi, and cosine pi is negative 1, plus c2 sine pi 0. So this is 0, c1 negative c1 equals 0. So that is c1 0. So negative c1 0 means multiply both sides by negative 1, c1 0. Now we can update 1 because c1 is 0, so this term is gone. So update the solution. Okay, and it makes our answer simpler. E raised to t minus pi over 2 times this term is gone, c2 sine 2t. So this will be our answer later after we figure out the value of c2. For c2, we use this initial condition, the second initial condition, y prime at pi over 2 equals 2. Okay, I also erase this one, the formula. So using y prime at pi over 2 equals 2. Okay, let's use this. So y prime, oh, then we need to find the derivative first. Okay, my bad. We cannot use that yet because this is y, but the initial value is y prime. So let's find the derivative. So the derivative of this one, c2 is just c2 constant. We got two functions. Product of two functions means we must use the product rule. Derivative of first factor, exponential function itself, times from the chain rule, derivative of top, 1 minus 0, because pi over 2 is a constant, so nothing, just 1, nothing. Derivative of first factor, leave second alone, plus derivative of second factor, which is sine means cosine 2t, times 2, I'm going to put here, times the first. The first is e raised to t minus pi over 2. Now we apply the initial condition. Y prime at pi over 2 equals 2. So y prime is 2 when t is pi over 2. So this is c2 e raised to pi over 2 minus pi over 2, 0. E raised to 0 is 1 times sine 2 times pi over 2 sine pi, which is 0, plus 2 times cosine pi, which is negative 1, and e raised to 0 is 1. So this is 2 equals 1 times 0 is 0. This is negative 2 c2. Divided by negative 2, we get c2 equals negative 1. Now we write the final answer from 1, just simply replace c2 by negative 1. Okay, thus y equals the final answer c2, let me put negative 1, just negative, e raised to t minus pi over 2 times sine 2t. Okay, final. There is another video without multiplying by this, and you get the similar answer, if not the exact one. Okay.